Even if you don't know how to do it, there's going to be somebody in that company, one of those tech guys. You get the tech guy and say, calculate me this. He or she is your calculator. Or alternatively, you build your own calculator and you go ahead with that. What's important is what you do with those numbers. These are going to be even more relevant when we talk about how to project the cash flows, how to think about uncertainties. If somebody gives me a calculator, I'm going to calculate stuff, then I'm going to think about quality of the inputs. Those are more important things. It doesn't matter to me whether that number is 2.1 or 2.4. What sort of things can possibly make that 3 or 1.5? You should be more concerned about those stuff instead of what the actual number is. That number is what it is. Does anybody have an argument for the value of the transcendental number E, the so-called Euler's constant? That's why it's called E, because Euler came up with that number. It's 2.718, blah, 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 blah. It's an irrational number. Similarly, do we have any disagreement about the value of pi? No, because we know what value of pi is. For on a circle, it's the ratio of the circumference to the diameter. That's it. Yes, it's an irrational number, but a calculator can tell me what it is up to 16 digits. If you want 1,000 digits, use an app called Mathematica. It actually will tell you up to 1,000 digits. If you want 10,000 digits, it's going to tell you that. Nobody should ever need that much, but the number is there. But if you know where E comes from, that's more important. Do you know where E comes from? Euler asked the following questions and he solved the equation. Have you guys heard of something called derivative in mathematics? It is basically the rate of change of a function at a certain point. Okay? Uh, and you can take derivative of stuff, for example, derivative of x squared is 2 times x. So think of the function x squared for x equals to 5. The slope of the curve when x equals 5 is 10. But the slope when x equals 1 is only 1. That means it's getting steeper and steeper. It is basically the rate of change function of a function. Euler asked the following question. Is there a function where all of its derivatives is equal to itself? So let's say f at 5, we don't know what that f is equal to 2. If you take the derivative, that's also equal to 2. If you take the derivative of the derivative, which is called the second derivative, that's also equal to 2. So if he's looking for a function where all of its derivatives equal to the function itself. These are called differential equations in mathematics, and you can either numerically or algebraically solve it. A lot of differential equations can be solved only numerically. He finds out the solution. The solution is a certain number raised to the power x. Okay. For that to be true, that certain number should be equal to e. That's the function. If you know where e comes from, that's more important than how it is calculated. If you, for example, calculating tangent of an angle, if you know what it is, that's more important than what the number is. Tangent is basically in any angle, the ratio of the adjacent side in any triangle, adjacent side versus opposing side. That's more important than what that number is. That's why I give you these things. And another reason I do, for a lot of different reasons, you guys come to this school with a lot of bad baggage from your math classes in high school. Some of you had good math teachers, some of you didn't have good math teachers. I always make the joke. People say, I'm so good, bad in math. There's no such thing as you being bad in math. I am not expecting you to be experts in algebraic topology, you know, the really uh, high level stuff. That means you simply did not have a good math teacher. I'll give you an example. You probably know or think that I'm a surgeon with mathematics, right? So I should not have had any issue in physics class in high school. I was barely able to pass that class. Why? Because I had a horrible physics teacher. He made me hate physics. If I had a good physics teacher, I would have loved physics. And more than likely, I would have studied theoretical physics in college. Later on, I mean, we had a high school class. He did not even talk about even special relativity. It was all Newton's mechanics, the planetary motion, the light stuff, electric currents, and that sort of stuff. They were completely boring. If we had talked about relativity, man, I would have been excited about it. For example, do you guys know that uh, without using the relativity equations, the special relativity, GPS wouldn't work? You know why? Because special relativity says if something is moving at a constant velocity, the faster it moves, the slower is the time for that. The way GPS works, I send a signal to the satellite, and satellite says, uh, and I record the time I send the signal. Satellite receives the signal, sends it back to me. But by the time satellite receives the signal, satellite itself has moved, right? So it has to send it back to me. Satellite is moving so fast, it is actually affected by special relativity. Without making that correction, uh, it makes errors up to, uh, a mile or so, depending upon the case. Because it takes time for signal to go from here to there. In the meantime, satellite has moved. If your high school people don't teach you that, and you don't know about it. Same deal here. You're not going to, I didn't cover, and I'm not going to test you on average accounting return. It is a completely useless investment criteria because it does not deal with cash flows. I mean, if you want to learn what it is, read the book, it's there. To me, don't waste your time. I mean, we will talk about depreciation and stuff on chapter 9. And these grad students put so many average accounting costs. Okay, internal rate of return. 3 years, 98.75, 10.50, 10.250, and 12.655. All I have to do is read off the IRR. In this case, it's just asking the IRR. The only thing I should ask myself, are the cash flows conventional or not? There are no negative future cash flows, so it's conventional. So if I had to make a decision using IRR, in this case, I just happened to have 14.6 there. I would have accepted the project, but slightly. Why? Because IRR is above my discount rate. That the fact that none of the future cash flows are negative. If one or more future cash flows are negative, that is non-conventional or unconventional cash flows. The entire concept of IRR is meaningless. So don't ever use it for any decisions because there may be multiple solutions. Let's suppose this had $10,000 negative cash flows. In fact, Excel couldn't even calculate it, which means the solution would have been below negative 100%. So let's put, it says 8219. Is that the case? I don't know. How about let's try, oh, here's another solution for you. Negative 2072. Which one is the proper discount rate? But luckily I have NPV. Based on NPV, I'm going to reject the project. But, it's also kind of